Okay, so while I talked about how you can replace the hardware at your leisure when drives go bad, when it does come time to do that, in the user interface we can identify and light up the carriers for that failed hardware. So even in the case where you have a helping hands remote facility where you have people who are not storage experts, they'll know which hardware to replace in the data center. Additionally, so drives can fail, but you can also have failures of the motherboard or power supplies. Something could be wrong with the chassis, but the drives remain good, even though the carrier that they're in has gone bad. Our disk drive volumes are they're self-describing, so you can literally take volumes out, take the drives out of one chassis, put a good chassis back in, and put the original drives back into the new chassis. You don't need to worry about the order that they go back in because the volumes are completely self-describing. The cluster will just figure it out. So we talked about how, as a storage administrator, I can see failed hardware in the system, and it's fairly straightforward for how I can go in and replace that failed hardware. Now, if I had lost a lot of hardware, I might have had a performance impact on the user. But in a lot of cases, the hardware, there's going to be more than enough capacity in the cluster to handle that. There are, of course, problems that can occur where it's going to take a more detailed view of the system in order to learn what's going on. And that's where we're going to have John Bell talk to you about how you can get additional information with our reporting.
Thanks very much, Eric. My name is John Bell, and I'm a senior consultant here at Coringo. And what I'm going to demonstrate for you now are the health report mechanisms that we have available to us to be able to further drill down and debug what's going on in your cluster should you report an issue. So this is our interface to the health report that's available within Swarm. As you can see, we have a comprehensive set of analytics that we can look at to determine the behavior of your cluster over time as it's undergoing various loads. It'll also show us the state of the cluster, information such as how it's licensed, what capabilities it has, what type of protection schemes you're using for your data, and so on. It also points out some of the top level things that we would look for if someone reported that there was a performance issue of some kind in the cluster. Typically, performance issues are going to be investigated at a top level in 3 categories. We would either look first at networking to see whether or not there were any network errors associated with the cluster. We would then go and take a look at drives and the drives' interactions with the drive controllers on the machines within Swarm to determine if there's any kind of I/O component to the performance issue that they may be seeing. And many of those statistics and more are captured here. For example, we can take a look at the load and associated maintenance cycles that are taking place within the cluster. As you can see, this is not a very busy cluster at the moment. Even though we do have a large load running, it's more than capable of taking on that load. So things are relatively quiet. We can look at history over time for how long health processor cycles are taking. As a health processor is working within a cluster, it may be grabbing more resources than it typically would in order to perform the functions that it needs to do in the case of an emergency, for example. And that could be an indicator as to why you're having a performance issue, so we take a look at information related to that. Just at a top level, we want to make sure that the protection status for the objects in the cluster are properly covered. Is the cluster status good? Is the data properly protected? In this case, even though we have a couple of bad drives in the system, overall the data protection is good. All the proper replicas are in place to make sure that data durability is maintained. You may want to look for things such as a large uptick in stream count. That could indicate an immediate impact on the system because all of a sudden you're taking on, as you can see here, a large ramp up in load that may result in the cluster being busier than it normally is, and it's something that a client may be able to see on their end. We also have statistics from a networking perspective related to how the cluster machines and nodes are interacting with each other in the form of cluster histograms. What we're looking for here is not so much a an overall value, we're looking for deltas, any large differences or nails that stand out in the overall cluster. We have a couple of examples here where we've had drive failures in this particular node on this machine, and that's reflected in the fact that its response times for replying to histograms has tailed up as a result. That could be an indicator that we need to drill down and take a further look at how this machine is reacting to a component failure, and whether or not potentially that's introducing a performance issue to the clients that are using the system. In addition to that, we can look at other factors in more detail. We can take a look at how storage is being spread across the system, across the volumes that are associated with each node in the cluster. There may be situations where, for whatever reason, one machine is capable of taking on more load than the others, but it gets to a point where it's the only machine that's taking on load because the others are busy with something else, and that may introduce a temporary hotspot in the cluster that goes away over time as the bidding algorithm and the balancing algorithms take care of that certain event. Last but not least, we're able to take a look at each individual node process, and we can take a look at networking items such as unicast traffic, multicast traffic, cycle times for health processing. We can take a look at SCSP operations that may be taking place and look for certain nodes in the cluster that are taking on more than the others to see if there's an unbalance for whatever reason, and then figure out what we need to do to address that. We can also see this evidenced in the form of any kind of obvious ramp up in stream counts that are taking place on individual nodes. Depending on how the bidding process gives its result to the client, some nodes again may take on more stream counts than others on writes, so you may see these ramp ups like this initially. These are also situations where if you just added equipment to the cluster to address an issue, you may see it taking on a lot more load quickly as the cluster balances itself out and takes advantage of the new equipment. But overall, the top level things to look at are more than captured in the health report, and can give you and the support team a very good visual into what's going on into your cluster should any kind of error or performance event be reported. If you can take a look at this, you can certainly figure out what's going on in your cluster with as much detail as you need to have to determine how to address the issue that's been reported. So as you can see, overall, our health report system addresses the top level characteristics that you need to investigate whenever somebody reports a performance issue or a potential error issue in the cluster. It'll show you all the statistics related to drive volumes, their associated nature with the I/O controllers, and ultimately the networking that pulls the cluster together.